Hello YouTube. In this video it's going to be a quick one about how to write the equation of an absolute value graph. That is, we're going to start with an absolute value graph that we already know what it looks like. So for example, this absolute value graph right here. And we are going to work backwards to what must have been the equation for this graph if it looks like this, okay? And so the key things to keep in mind here are going to be these. The fact of the matter is every absolute value equation, the standard form of the absolute value equation is a times absolute value of x minus h plus some k value, okay? So the three values we're going to need here are we need a, h, and k. So you might recall from previous videos or from prior knowledge that h and k happen to be the x and y values respectively of the vertex. So that's going to be easy to determine. For example, if we were to look at this graph right here, we notice that the vertex is at 2, 1. And then we're going to be able to determine an a value just by looking at this as well, just how we go about doing so. So one thing that would be nice is if anybody's wanting to know how to do this in general, you can write down this process that I put over here, but we'll go through these 4 steps and I would like to read through them first. So the first thing we're going to do is determine the coordinates of the vertex, and like I kind of mentioned over here, the vertex, recall, the vertex is always at h comma k. So if we know the values of the vertex, then we actually know h and k respectively, the x and y values of our vertex tell us h and k. Okay, so once we determine that, so for example, we can go ahead and as we go through the steps, we'll look at this graph over here, but take a look. Excuse me, I'll drop in a point here at our vertex, but we notice that this point is over 2, up 1. So for example, this specific graph, we could say that the vertex is at 2, 1. So what this implies is that must mean that h is equal to 2 and k is equal to 1. Okay. So the next thing we're going to do is say step 2. It says find a point on the graph that lies to the right of the vertex. Now this is important. I say to the right of the vertex. If I were to put in the line, and we'll put this in here, we say x equals 2 in this case, and what I'd like to do is change the properties of this line. So you have to bear with me for just a second. I'm going to change the style of it so that it's dotted or dashed line. You can kind of see this here. That's our axis of symmetry, but we want to pick a point to the right of our graph, so to the right of the vertex. And I mean by to the right, we say any point on the graph so long as it's to the right of the vertex. So for example, I could choose that point, I could choose this point up here, or any of these points, but we need this point. And the reason why is because it's going to help us determine our a value. So once we get a point, I have 3 of them, we'll use one of them, but it says determine the slope of the line passing through the vertex and the point that we just found in that part 2. This is our a value. So looking at this graph over here, if you notice I say, well, I want the slope of this line that goes through the vertex, that point of the vertex in any of these points. So for example, this is our line here. I could find the slope from point A to point B. We say it went up 1, right 1. So up 1 over 1, that's a slope of 1. We could have said the slope between A and C. Say we had chosen C. We didn't have B in there, or nor did we have D. We say, okay, well then from A to C it goes up 1, 2, 3, over 1, 2, 3, up 3 over 3. That's still a slope of 1. Okay. The nice thing about that is it doesn't matter which point you choose on the right, but we're going to find the slope between the vertex and that point. And I say, okay, this is our a value. So in this case, what we just determined was this. We've determined that our a value in this instance was 1 over 1, or 3 over 3, or just 1. So now that I've mentioned this, it says step 4 over here. It says put these values into the standard form of the equation of an absolute value graph. So the standard form of an equation of an absolute value graph is actually this equation right here, and like that dot right there. So this is something I always stress to my kids at least. Before you start plugging things in, let's put in blanks for the stuff we're going to plug stuff into. So we say we're going to plug in for A, we're going to plug in for H here, and we're going to plug in for K. And the reason why is because if you don't do this, you're going to mess some negatives up possibly. So we say, all right, so H is here, K is going to go here, and then A is going to go here. And so we say A. I got ahead of myself here. So A, we said A was 1, H was 2, positive 2, and then K was 1. So if I clean this up a little bit here, keep these things in mind. You can't distribute through absolute value bars, so that's not going to happen, even though that is a 1. But we say the equation of this is just 1 times anything is itself, so we'll just leave it as just blank out front. We say x minus 2. It's actually x minus 2 in here. We say plus 1. And this is our equation. And as a matter of fact, I hate to spill my guts on these over here, but basically if you look up over here, that was the equation of the absolute value graph. So now we're going to take a look at this next one here and say, well, you know, it's not a bad thing to see what we have right off the bat. It's -2 absolute value of x, and you can look down here at the graph now. Whoops, I didn't want to do that. So let me unhighlight these points here. Take a look at your graph. Okay, so we say we want to go from the graph to the equation. We need a couple of things. First of all, we're going to need to know the value of the vertex. So the vertex is at 0, 0 this time. So we'll hop back over here, and maybe we switch colors because we're in a new example, and I don't want to be ambiguous here. So we say vertex. We'll come over here. We say vertex is at 0, 0. We said next we'll find a point, some point on the right-hand side of this graph. That's, oh, obviously that's a point right there. So between the vertex and this point, we say it went down 4/2. So this is our a value here. We say a is down 4, right 2. That's -2. So now we have a, we have h, we have k. Let's go ahead and pop these suckers in. So we say y equals a times absolute value of x minus h plus k, pardon me. And so we say, okay, so h and k, oops, wrong button. H and k is 0 and 0 for h and k, and then we say our a value is -2. So that's how we end up with just y is -2 times the absolute value of x. Because those zeros, they have not a whole lot of bearing on our line here. So, or our absolute value graph. Okay, going back over to GeoGebra here. I won't let you see the equation this time, and I know you probably can't remember, but take a look down here. First thing I would like to do is let's go ahead and identify the vertex. It seems to me that the vertex is left 3 down 2. So -3, -2. So going back over here, not Twitter, here. You guys are being patient with me, I can tell on the other end. Hopefully. We say we'll go to, how about orange? We say now, okay, so this graph here, we say the vertex is at -3, -2. Now we need an a value. So a value, we just needed to pick some point on the right-hand side of this graph. It looks to me like it goes through that point rather, just fine. So from G to H, we say it goes up 1, right 3. It goes up 1, right 3. Then we say our a value is just 1/3, rise over run kind of thing going on. So we say now our equation is y equals a. And if you're getting the hang of this, you don't have to put in these parentheses every time. It's just that if you don't, you're running the risk of messing up of anything. Your h value is what you'll screw up, is what I'm guessing. That's what happens a lot. But we say, okay, so a is 1/3. H is -3. So we're actually going to put a -3 in here, and you might foreshadow what's going to happen inside this quantity. And then -2 was our k value. So we say, cleaning this up a little bit, we just say the 1/3 out front. That's our a value. We have minus a -3. So that's the same thing as +3. And then we say plus a -2. That's the same thing as -2. So of course this would be a graph that has a vertex at -3, -2, and goes up 1, right 3. And that's exactly what you see over here. So that's basically, it's pretty straightforward writing the equation of a absolute value graph. You just need to know the vertex and the a value, and you plug that back into the function.